Okay, so to do these questions, what we have to do is work out the mass of the formula. So in this first one, here is the formula, and I can see from this that there is 1 carbon and 4 hydrogens. What we then do is we go to the periodic table and we find the relative atomic mass. I've actually included them here to help you. So I see the mass of carbon is 12 and the mass of hydrogen is 1. So let's swap those in. So I've got 1 times 12 is 12. Mass of hydrogen is 1, so 4 times 1 is 4. Then we're going to add these up, and that gives me an answer of 16. Okay, what I'm going to do, you need to do the working out the same in each one. I'm going to fill this in for you, the answers, and you can check your answers and tick them and check the working out if you got it wrong to see where you went wrong. Okay, so these are the answers to the remaining questions in that task. Just make sure, if you're getting them right, give them a tick obviously, but if you're getting some wrong, use the working out to see where you have gone wrong. Things to watch out for are where we have these brackets, because remember the number outside the bracket multiplies everything inside the bracket by that number. So that means here there's 1 sulfur, but we have to times it by 3. So I've got 3 lots of sulfur. There are 4 oxygens. I have to times that by 3. That gives me 12 oxygens here. So just watch out for little traps like that, but check them off. If you get them wrong and you can't understand why, if you come and see me, I will help you with that. Okay, in these questions, we are being asked to calculate the mass. And to do that, we use this triangle that mass is mR times moles. Mr. Moles is underneath the mass, is the way we work this out. So if we want to find the mass, we cover mass over, and mass is mR times moles, as we said. So here I'm going to write that down so I remember what I'm doing. So it's mR times moles. The mR in this case, we're told here, is 63. That's the mass of the formula. And the question is 0.5 moles. So we've got 63 times 0.5, which is going to be 31.5. And that is going to be grams of substance. Again, do the same working out and then check the answers in the next section of the video. Okay, so here are the answers for the remaining questions. Again, if you check to see if you're getting them right, if you're getting them right, brilliant. If you're not getting them right, have a look at the working out. Make sure you can see where the numbers have come from. And if you're still unsure, please come and let me know. So again, in these questions, we're going to use this same triangle that Mr. Moles is underneath the mass. But in these questions, we're actually trying to calculate the moles. So if I just write down moles to show that's what we're trying to find. If I come back to the triangle for a moment, so moles is here. That means moles is mass divided by the mR. So let's just write that down so that we know what we're going to do. And if I look at this first question, you can see the question says that the mass is 14 grams. The mR is, this is an atom, so the mR is equal to the relative atomic mass, which is 56. So here I've got 14 divided by 56, and that equals 0.25 moles. Okay, so try the others. Again, I'll put the answers up for you to make sure you are happy with what you have got. So again, check that you are getting all the answers correct here. If you're getting them wrong, let's look at where they've gone wrong. So check your working out against what I have done. And any questions, please let me know. So these questions are a little bit trickier. What we're going to do here is we are going to first of all take this mass and convert this mass into moles. And I'm using this triangle here. So we've got the mass, we want to know the moles, so the moles is mass divided by mR. So let's do that first, that's my first step. So we have got, want to know the moles is the mass divided by the mR. In this case, the mass is 14, the MR is 12. So I've got 14 divided by 12, and that's given me, I'm going to round it up to one decimal place, 1.2 moles. Okay. The second step, what I now need to do is take this number of moles and convert it into the number of atoms inside this mass. To do that, I need to use this second triangle here. So what I'm trying to find, the particles are, in this case, the atoms. So I want to find the particles. So the particles is moles times by Avogadro's constant. And Avogadro's constant, we're told, is this value. So let's just write that equation down. So we're trying to find out the particles, which for us is the atoms. We're going to use the word particles, and it's going to be moles times Avogadro's constant. The moles in this case is 1.2. I'm going to times it by Avogadro's constant, 6.02 times 10 to the power of 23. So I've got to put it into my calculator. And that's giving me an answer of 7.22 times by 10 to the power of 23. I'm just going to put atoms there because this question asked me to work out the atoms. Okay, each question here is an opportunity to practice that. So again, pause the video there, practice the questions, and then check the answers that you have got. So again here, pause the video for as long as you need to check the working out, but the same format for each calculation, and we've got the particles worked out as you can see for each one. Something to bear in mind here, again, if you're not getting this right, please go back and check the working out, check where it's gone wrong, see if you can see what you've done, correct it. If you're not sure why what you've done is wrong, please do come and talk to me about that. Okay, this next set of questions are a little bit tougher. These would definitely be more higher tier calculations. You wouldn't see these on a foundation paper. So what we've got to do here is, this one says calculate the number of chloride ions that's in 1 mole of this magnesium chloride. So the first thing to do is I'm going to write down here that if we have 1 mole of this MgCl2, I can say that's giving me 2 lots of chlorine. So it's going to give me 2 moles of chloride ions, because that's what they're made up from. So what I need to do now, and I've got 2 moles of chloride ions, I want to work out the actual number of ions, the particles. We're going to use that triangle that we used previously, and that triangle is that the moles is the particles equal to moles times AC. So the moles we just said is 2. Avogadro's constant is 6.02 times 10 to the power of 23. So that's going to be 1.204 times 10 to the power of 24. And that example is ions. What I'm going to suggest you do, pause the video there, try the others. I will then put in the answers. You can check against them to see how you have done. So again, here are the answers. Please just pause the video so you can check them out. The ones that are trickier are, as you can see here, we want to do 3 moles of this aluminium sulfate. So if we look at 1 mole contains 3 moles of this sulfate. This is the sulfate here. So therefore, if I have 3 moles, like the question asked me, I've got to do 3 times that 3, so I've got to get 9 moles here. So that means 9 is the factor I've got to multiply by. Similarly over here, this wants me to do 4 moles of chloride ions. So 1 mole is equivalent to 2 chloride ions because it's Cl2. Therefore, if I've got 4 moles, I'm going to get 8 lots of chloride ions. So 8 is the factor that I need to multiply this by. So to do empirical formula calculations, we use this method, this approach again, this triangle approach. And what we do first of all is we write down the elements involved. So the elements that are reacting together are, in this case, magnesium, which is Mg, and we've got oxygen. And the first step is to write the mass. And we can see from the question we've got 48 grams of the magnesium and we've got 32 grams of oxygen. Next step is to write down the MR. So these are atoms. So the MR is the mass of the atom. So you can see from what's been given in the question, we've got 24 for magnesium and 16 for oxygen. So what we have to do now is we've got the mass, we've got the MR, so we now find the moles. So the moles is mass divided by MR, which is why we write it like this, because it's this number divided by this number. So my moles here is going to be 48 divided by 24 and 32 divided by 16. That's going to give me 2, and that is also going to give me 2. The final step is divide by the smallest number. So in this case, both the smallest numbers are 2. So I'm going to do 2 divided by 2 and 2 divided by 2. So that's going to be 1, and that is going to be 1 as well. This means that my empirical formula is Mg1, Mg1O1. So it is just MgO because we don't write the ones down. Again, try the ones below. There's some traps in there, so be careful, and then I'll put the answers in for you to check your responses. So this next one here that you can check, just be careful because when you do the method, you end up with 1.5 and 1. And what I have to do to keep this ratio the same is multiply this by a number to get a whole number, because obviously we cannot have 1.5 of a calcium. So what do I times 1.5 by to get a whole number? If I times it by 2, that's going to give me 3. But I must do the same to this side as well. So both sides get times by 2. Therefore, it's calcium 3N2. And there is my formula to show that. Okay, to do these type of questions, what we need to do first of all is take this empirical formula here and work out the mass of that formula. So that formula is CH2. That means it's got 1 carbon and 2 hydrogens. Carbon has got a mass of 12, as you can see, and hydrogen's got a mass of 2 times 1, so hydrogen's mass is 1. So that's going to be 12, and that's going to be 2. Add them up, and the total mass there is 14. So this formula, there's the empirical formula, has 14. The empirical formula is the simplest ratio for a formula, so this is the simplest ratio, and it then goes on to say that the actual whole molecule has a mass of 70. So what I need to do is divide this out. If the whole molecule is 70, but this part that we're looking at is only mass of 14, if I do 70 divided by 14, 70 divided by 14, that's going to give me an answer of 5. So what I need to do is multiply this factor by the mass of this. So this has got to be 5 times bigger. So let's just do that now. So here we have got CH2. We're going to times it by 5. So that's going to give me C5H10 as a total formula for this. And if you add this up, then what you end up with is a mass of 70, which is what you started. So 5 carbons, 10 hydrogens is mass of 70, which is what it should be. So to work this out, what we've got to do is exactly the same thing. Work out the mass of the empirical formula. So we've done that here, and I get 14. The mass of the relative formula mass is 154. Divided by 14, that gives me a factor of 11, which means this formula here must be 11 times bigger. So we take that, times it by 11, so we get C11 and then H22, because 2 times 11 is 22 hydrogens.